Assalamu alaikum. So this is an example how to integrate using Riemann Sum. So I'll try to go in detail. So in that case, you get the point. Let's write this one in limit form. So this will be equal to limit of sum from 1 to and go to infinity here. So here it's gonna be x star square plus x star turn delta x. So we need to define what is xr star, xi star, and define delta x. Delta x is the length of the subinterval, so it's going to be delta x will be equal to, by definition we always pick the boundary, so it's going to be the 0 minus 2 over the subdivision. We have n subdivision, so here is going to be 2 over n. So this is the delta x. Now the x star is the midpoint, so to find out the midpoint, we know that the midpoint is the midpoint of the endpoint. So first thing I need to find out is the endpoint. So I'm going to find out what is xi. Xi is always the first boundary, which is minus 2 plus I delta x, which is equal minus 2 plus I times 2, which is 2I over n. So this is the endpoint. So I need to find out the second point, which is xi plus 1. So in that case, I will get my midpoint. So it's going to be equal to minus 2 plus 2I plus 1 over n. So this will be my second. So to find out my x star I, which is my midpoint, so what I do xi plus 1 plus xi over 2. So using the midpoint formula. So it's going to be minus 2 plus 2I over n plus minus 2 plus 2I plus 1 over n, and the whole thing is over 2. So here I will have minus 2 minus 2 is going to be minus 4. So if I distribute this one here, I will have plus 2I plus 2I plus 2, and it's over n, and the whole thing is over 2. So if I do 2 here, like 2 here, so it's like I'm flipping here. It's going to be minus 2, and here is going to be plus 2I plus 1 over n. So what I did here, I combined those, so it's going to give me 4 divided by 2. I divide by 2, so to get my 2I, and here is going to be 2 divided by 2, it's going to be 2, but the n still for both of them. So this is going to be my midpoint. So xi will be minus 2 plus 2I plus 1 over n. Or you can do it in this format, minus 2 plus 2I plus 1. If we proceed and you multiply by 1 over n. So this is more better. So this is my midpoint, this is my dx. I just need to substitute this value into this expression and simplify. So this is what I'm gonna do now. So let's organize my table here. So I'm gonna erase this, put only 2 over n here, so this I know is my delta x, and I put my x star I, which is minus 2 plus 2I plus 1 over n. So I can erase this part, I don't need it anymore. So alright, now let me substitute this into my limit. So I will have limit when n go to infinite. So I'll go from 1 to n, and here I substitute my value here. So it's going to be minus 2 plus 2I plus 1 over n, so square the whole thing, plus minus 2, so this is here, so times 2I, this is I, plus 1 over n, and the whole thing is delta x, which is 2 over n. So 2 over n, it doesn't depend on I, so I can pull this one out here. So it's what I'm going to do now. So it's going to be limit anything which doesn't depend on I can pull out out of the sum. So it's going to be 2 over n sum, and I go from 1 to n. And here what I do, I FOIL. So keep in mind, this is your A, this is your B. So when you FOIL, so it's going to be a squared plus 2ab plus b squared. So remember, this is going to be a plus b squared. So it's going to be a squared plus twice ab plus b squared. So it's going to be 4 plus twice this. So it's going to be minus 2 times 2 is going to be minus 4. So it's going to be minus 4 times 2I plus 1 over n plus this 1 square, which is 2I plus 1 square over n square. And here what I do, I just like distribute 1 over n because I need it for later. So it's going to be minus 2 plus 2I over n plus 1 over n. And remember, this we already put it out, so I don't need to write it down again. So now what I do, I FOIL this and I distribute whatever here and I combine action after that. So it's going to be limit, so it's going to be 2 over n sum equal 1 n, and here's going to be 4. Here it's going to be if I choose, going to be minus 8 over n I, and minus 4 over n. Here if I FOIL here, it's going to be 4i squared plus 4i plus 1 over n squared minus 2 plus 2 over n I plus 1 over n. So this is 1 over n. Let me clear it. Okay, so now what I do, I split, I come back to if there's something I can combine. So n to infinite, 2 over n sum. Don't distribute the sum here till you make sure that everything is simple, so there's nothing repeated. So I have 4 minus 2 is 2, so this is gone. Then I have minus 8 over n I, and minus 2, so it's going to be minus 6 over n I. So this has nothing to do with this because there's no I here, so I have this with this, so it's going to be minus 3 over n, and here I split it out, so it's going to be 4 over n square I square plus 4 over n I plus 1 over n square. This is square. So now this is the simplest form I have here. So now what I do, I distribute the sum to each terms. So this is what I'm gonna do now. So it's gonna be, let me copy it and put it on the other board. So in that case I will so this is my limit, and here is minus 2 0 x squared plus x dx. Now so if I distribute, I got limit when n go to infinite, so the 2n I will have it always outside, so it's going to be the sum I equal 1 and 2 minus this does not depend on the sum because there's no let me put it first, and at least you don't get confused, and I will give you the property. So distribute the sum, don't do double work on the same work. So here So 1 to n, 1 to n. Alright, so now I need some properties. So if I have the sum of k a I going from 1 to n is the same thing if I have k, the sum of I going from 1 to n. So I can pull out the k as common factor. The second property, if I have the sum of what you call it, like a constant, I going from 1 to n, so is just k times n. So you need to know this. And this is the sum if I have I from 1 to n is n plus 1 times n over 2. The sum of I from 1 to n of I square, which is what I need here, is going to be n times n plus 1 times 2n plus 1 over 6. So you need to know this. There's a third one which is I don't need it here, but I just want to write it down for you. So I cube from 1 to n, so it's going to be n times n plus 1 times n over 2, and the whole thing square. So those properties, you need to know them in order for you to finish this Riemann sum. So I'm going to use those properties here. So let me erase those now, so at least you got them. So here, like I told you here, it's going to be the limit and go to infinite 2 over n. So this is just a constant, so it's going to be 2n minus, so this is the constant I have, ki, so I can put out the constant out. It's going to be 6 over n, the sum of I going from 1 till n. The same thing here, this is 3n, so this is a constant, even if I ever can pull out outside, but this is very simple. I just need to do 3 times n over n, so it's going to be 3n over n. I can simplify the n, plus here I will pull out this constant out, so it's going to be 4 over n squared sum I square. You see what is constant for me here? It's something that doesn't have I. So this doesn't have I, so I put it out because it's a product. It's going to be repeated all the terms, so it's like a common factor. And same thing here, it's going to be 4 over n squared sum going from 1 till n I, and here is going to be just n over n squared, which is I can simplify. I will have only one here. So let me write it down now. 2 over n, so it's going to be 2 over n. So now I simplify this with my formula, so it's going to be minus 6 over n times n plus 1 times n over 2. So this is this formula, plus 3 plus 4 over n, then I switch this one to the formula that I just showed you before. So it's going to be n plus 1 times n times 2n plus 1 over 6. Oh, this is 4 square. Alright, and here it's going to be 4n square, and here is going to be the formula, which is n plus 1 times n over 2 plus 1 over n. Now what I do here, I simplify if I can. So this is the n, simplify, and I will have limit when n goes to infinite 2 over n. So here you have to be careful, because when you have a lot of stuff to work on, so you have to be careful. So here I can simplify, this is 3, so it's going to be minus 3 n plus 1 plus 3, and here I can simplify this. This is 2, this is 3, so I will have plus 2 and n plus 1 2n plus 1 over 3n square plus 4, this is can be simplified, that's going to be 2n plus 1 over n square plus 1 over n. Now what I do, I distribute the n here, so I got limit when n go to infinite, so I distribute the 2n, so it's going to be 4, so this time this is going to be 2n, 4n over n, so it's going to be 4. So here I will have 6n plus 1 over n plus, and I will have 6 over n. Here I will have 4, the n and the n cancel out, so it's going to be 4 n plus 1, 2n plus 1 over 3 n squared. And here again it's going to be 4, the n will cancel out, so it's going to be 4 n plus 1 over n squared, and here is going to be just plus 2 over n squared. Then after you do the limit, so the limit here is straightforward, so I will have the integral minus 2, 0, x squared plus x dx. So here what I do, I work on my limit. So here, so it's going to be the limit when n go to infinite of 4 minus the limit of 6n plus 1 over n when n go to infinite, plus the limit of 6 over n when n go to infinite, plus the limit when n go to infinite of 4 times n plus 1 times 2n plus 1 over 3n squared, plus the limit 4n plus 1 over n squared when n go to infinite, plus the limit 3n squared when n go to infinite. So we know that this is 0 because the degree of this one is 1, this is degree 2, so obviously this is 0. So those, if I multiply this 4n and multiply with 1, is going to be 8n, so it's going to be 8 over 3 because the n squared will cancel out, so here will be 8 over 3, and here is going to be 0, here is going to be minus 6, and it's going to be 4. So because there's no n here, so it's going to be just 4. So now what I do, I just also is going to be minus 2 plus 8 over 3, so it's going to be 2 2/3. So I hope this is clear. So if any comments, so please, I'll be happy to hear from your comment. Thank you very much and good luck.